Okay, class. So, for the last topic here that we are going to cover, for Biot-Savart law, we have the magnetic field that is generated by a long, thin wire, right? So this case here is the third case for our Biot-Savart law. It's a long, thin wire. So what makes this different than our first case? Our first case was, remember, a small segment of wire, a small segment kind of like this. So we have this little dx or dl segment of wire, and it creates some contribution of magnetic field to point P. But now what we're going to do is, this has an angle, right? We solved this. We have an angle. We have a radius. We've done this for part one. Now we're going to take the segment next to it and the segment next to that, the segment all the way here on the edges. We're going to have all possible angles and all possible radius values. So like, a very, very long wire, and we can just integrate kind of over this entire thing, okay? Now, we won't go through the derivation here. This will be a little bit outside of the scope of what we're going to cover for this video. But to simplify this, kind of going through, we can, of course, simplify our Biot-Savart law. Remember our Biot-Savart law being this integration over the entire wire here. We're going to go ahead and do this. For our long, thin wire, we will end up with B is equal to mu naught I over 2 pi r, where r here is my radius value, the distance from my point to my wire, right? So this is always going to be perpendicular. So since we're talking the whole wire, not just a segment, then it's very easy. Wherever our point is, we just take the distance from the wire to the point perpendicularly. Okay, so here's our formula. And just like before, let's go ahead and put an example in to get the hang of how this works. So let's say that I have a wire here, and it is, again, a long, thin wire, and we have some current going here from left to right, and we have a point that is half a meter away from the wire, okay? So this one, I'm going to flip it a little bit on you. Instead of looking for the magnetic field as we did in the previous examples, I want to ask, if you measure the magnetic field right here, so if you take this magnetic field at this point and you measure that it is 8 microtesla, okay, micro, be careful with your prefixes here, then what is the current in this wire? So this will be the example we work with here. So let's try to apply this formula. So I want you guys to do, go through, pause the video, try to work through this example to find the current in the wire if you measure 8 microteslas of magnetic field half a meter away from that wire. Okay, so what we should end up with here, we're starting with our formula here. We're looking for current. So what I like to do, of course, before we even hop in here, is try to get current by itself. So if I do this, for example, if I multiply by 2 pi r, if I multiply both sides by 2 pi r, okay, then this will cancel here on the bottom. And if I divide both sides by mu naught, then I'll cancel out here mu naught on the right hand side. So what I'll end up with is I is equal to 2 pi r magnetic field over mu naught. Okay, remember that mu naught, my permeability of free space, is 4 pi times 10 to the minus 7. So let's go ahead, and we have all of the information we need here, actually. So my radius value is 0.5 meters, okay? And my current value, my current is on the left-hand side. We'll leave that here, right? That's what we're looking for. And then my magnetic field value here that we measure at this point is going to be 8 microtesla. So you can see, since mu naught is a constant, everything else here is a constant. We have all of the information we need to find I. So let's go ahead and do this. Here what we're going to have is I is equal to, this is 2 pi times r, which is 0.5 meters, okay, times my magnetic field of 8, and then remember micro being times 10 to the minus 6 Tesla, okay? All of that divided by mu naught, which is 4 pi times 10 to the minus 7, okay? So now we have all of our values, so we can calculate this. So when we simplify it, okay, so if you do this in your calculator, go ahead and try this out now. If you had some error, go ahead and fix it up and try it out now. What we should have here is that my current running through here should be 20 amps, right? So again, we know based on the magnetic field a certain distance away. So we measure this magnetic field a certain distance away from the wire, in this case, 0.5 meter away. Anywhere along this wire, 0.5 meter away, if we were to measure the magnetic field, we would get a value of 8 microtesla. So I know that the current in the wire has to be 20 amps. This is a huge amount of current, but we got 20 amps in this wire that is carrying our current that is making the magnetic field. It's inducing a magnetic field, right? So this is a quick example of how to use this third form of the Biot-Savart law, right? Remember, our magnetic field of a long, thin wire, okay? So don't forget, to review all three, we have magnetic field of a small segment of wire. This was the first case. Magnetic field of a circular arc of wire. This was the second form that we looked at. And then our third form here, magnetic field of a long, thin wire. Be sure to review all three of these.